Greetings to everyone. I'm Kamini Somasundram and my supervisor is Dr. Chanuri Charin. I'm from School of Electrical Engineering Technology, University Malaysia Perlis. I would like to present about the study on the performance of different optimization algorithms in maximum power point tracking for a standalone photovoltaic system. We will focus on few sections in this presentation: introduction, problem statement and objective, MPPT algorithms, results and discussion, and conclusion. Introduction. Currently, we are facing our surroundings feels warmer than the usual. This occurs due to the greenhouse effect. The greenhouse effect is a process that occurs when gases in Earth's atmosphere trap the sun's heat. The greenhouse gases are the main reason of this cause. So to avoid this, we need to use the renewable energy, which will not produce any greenhouse gases. In terms of cost and operational way, solar is preferable compared to all other renewable systems. So in order to convert the solar energy to electrical energy, we need a PV cell to, to convert it. Okay, this is the example of a standalone photovoltaic system. So there are four important elements in this system, that is solar array, charge controller, inverter, and the load. Next, problem statement. Conventional systems could only track the MPP when the weather was consistent. Traditional MPPT algorithms generate oscillations that are similar to the MPP and are ineffective for large-scale solar power plants. So, the objective of this research is to study and evaluate on the performance of different optimization algorithms in MPPT for a standalone PV system based on the previous studies under various irradiances via MATLAB or Simulink simulations. So, this is the schematic diagram that been used in this study. There is four important elements that been included in this schematic: PV array, boost converter, MPPT controller, and so this is the specifications of PV module that been used in the simulation. So the Pmax of the PV module is 50.04 volt and the open circuit voltage is 22.5 volt. The short circuit current is 3 amp. Voltage at the maximum power is 18 volt and the current at the maximum power is 2.78. So the number of Next, this is the PV curve of the PV module that been used in the simulation. So from here we can see under various irradiances, the PV values is also different. So for 1 kilowatt per meter square, the power value is 50.04. So for 0.6 kilowatt per meter square irradiance, the power value is 30.4891, and for the irradiances of 0.2 kilowatt per meter square, the power value is 10.091. Next, MPPT algorithm, the perturb and observe P&O algorithm flowchart. So we can see from this flowchart, it initializes the P&O parameters and determine the optimum power. So there is some advantage and disadvantage of this P&O algorithm. It is simple and easy to use, but it's unable to track the exact optimum power point. Next, particle swarm optimization algorithm. From the flowchart, we can see it initialize the PSO parameters and determine the optimum power. There's also advantage and disadvantage of this algorithm. Its advantage is it has zero steady state oscillation and its disadvantage is it has lower tracking speed. Next, salt swarm algorithm. So from the flowchart, we can see that it initializes the SSA parameters and it determines the optimum power. So there is also advantage and disadvantage of SSA. So its advantage is it reduces power loss, but its disadvantage is its steady state fluctuations and inefficiency of tracking. Next, results and discussion. In this section, we will see the PV power of P&O PSO and also SSA under the irradiances of 200 watt per meter square. So from this simulation, we can see the oscillations of all three algorithms is low. Somehow, the response times of P&O is lower and the PSO is medium while the SSA is faster. Next, we will see the PV power of P&O, PSO and SSA under the irradiances of 600 watt per meter square. From the simulation, we can see that the oscillations of P&O is high, PSO and PSA is low. While the response times of P&O is failed, this is because it couldn't track the optimum power point. Also, the PSO as medium response time and the SSA as the faster response time. The PSO still have some oscillations before it reach its steady state after tracking the maximum power point. While the SSA, we can see that the oscillation is very less when it achieve its steady state. Next, we will see the PV power of P&O, PSO and SSA under irradiances of 1000 watt per meter square. From the simulation, we can see the oscillations of P&O, PSO and SSA, which is the P&O as the highest oscillation and PSO and SSA have the lower oscillation. So for P&O, we can see that it already reached its optimum power, but it still have the oscillations. So next for the PSO, we can see it already reached the optimum power, but there's also few oscillations compared to SSA. So for the response time, the P&O as the lowest response time and the PSO as the medium response time and the SSA as the fastest response time. Next, conclusion. So we have compared three algorithms, that is traditional and also soft computing. P&O is the traditional MPPT algorithm, while the PSO and SSA is the soft computing algorithm. So when comparing to all the simulations given by all the three algorithms under various irradiances, we can see that the results of SSA is the best. So SSA is the best performer compared to other two algorithms, that is P&O and PSO, because SSA have the lowest oscillation, fastest response times and highly efficient under all irradiances. That's all for my presentation. Thank you.